many people, well, let's do the obvious first. How many people are either aware of or have attended VMworld? Okay. Anybody take part in the hands-on labs this year or previously? Okay, so is everybody clear about exactly what we're talking about with the hands-on labs? We've kind of made a gross assumption here that, one, you know what VMware is. We hope you do that one. Second, you know what VMworld is. There's a few more nods, so I'm hoping that's okay as well. It's their annual show, their trade show, effectively, and their show for partners and customers. It occurs twice every year. It's actually split across 2 geographical locations. So VMworld is actually hosted, or this year was hosted in Vegas, which is much the larger show. The Vegas show is something in the order of around about 20 to 25,000 attendees. It's one of the bigger trade shows that you see every year. And then subsequently, around about 5 to 6 weeks later, it runs a second time. This time it runs on a slightly smaller scale, but basically the same principle of operation, but it runs in Europe, in Copenhagen this year. So that one finished last week. We all returned to Copenhagen and came straight here to the OSS Summit. So that's basically VMworld. What about the hands-on labs? As far as hands-on labs, everybody understand what we mean by that? For those people who don't, if you attend VMworld as a delegate and you pay your standard entry price, then you effectively get the opportunity to partake of all of the new technology labs. Effectively, VMware use this as a showcase to push the idea of training most of their customers, most of their partners on any technology that's being designed and developed that year. So, for instance, this year there was a significant number of labs, something in the order of about 26 different labs, that were written over the 5 to 6 months before the show, and then were delivered. Everything is delivered on the VMware platform. Surprise, surprise. Everything is actually delivered directly there and then, and you'll see some of the details later on as we go forward.
So the design for the Super Rack, as VMware call it, was based on a lot of our technology and a lot of VMware's technology partners, some of which you see up there. We see data on who are here. They've got booth outside demonstrating some of their JBoss technology. S-Tech for SSDs, our storage software, Supermicro head nodes and compute nodes. That technology was provided as a complete rolled out solution by a company called MDSV, who are based here in California. Okay, so what were the requirements for the Super Rack? So the requirements for that was to be able to run high density generic cloud workloads, and really no one can tell us what the workload that they were designing to it was. What's the best sort of cloud pod design that you can deliver us? So it was a fairly nebulous design spec. The differential here was we were asked to provide a cloud pod that was based on a cost per terabyte as the primary design configuration. IOPS were important, and obviously are important. If you run out of IOPS, customers' applications are going to start to slow down. But we really were tasked with a very aggressive cost per terabyte price. It had to be delivered on completely commodity x86 hardware. And it was asked to be able to scale out based on file services from NFS and be able to be a pod design, but with the ability to scale a single point of entry file system for some future developments within VMware.
So hopefully one of the things that you've already maybe picked up is the fact that although we started this by saying we'll talk about the hands-on labs and we'll talk about the deployment for VMworld's hands-on labs, specifically this design was not put together for the hands-on labs. We were initially approached to actually put together something which would be deployed by VMware as part of their vCloud initiative. So this is to design a generic cloud platform that can be scaled out very easily, that can be deployed so that they can actually build themselves out as a public cloud infrastructure provider. Subsequent to doing that, they then slightly moved the goalposts. Slightly moved the goalposts in this case means we've got all the hardware, we've got everything in prototype, we're actually building out the design. The design that we'd actually laid out was slightly changed because they then threw the curveball, and the curveball this time was that, hey, the hands-on labs are coming up. That's a fantastic baptism of fire. Let's see how your solution works in the hands-on labs. Because from a hands-on labs perspective, it's a completely different ballgame. We're really talking about moving. Sorry.
And if someone had come to us and said, we want you to design a platform to run the hands-on labs, we would have made some slightly different design choices.
The design would have been quite different. Okay? What we're looking at here is the design of the super rack is really based around designing a cloud where we're going to be running a commodity set of hardware, but more importantly, we're going to be running something upwards of about 5,000 kind of VMs running within this environment of indeterminate content and also size, because they're going to be offering this publicly to all of us. So consequently, taking this and turning it into the hands-on labs and making it perform was an interesting challenge as well.
So as you can see, Super Rack is a 2-rack solution. It's based on a Arista, top of rack switching and core switching. It's based on Supermicro commodity servers. It's a mixture of their blade, and I don't know if any of you are familiar, their 2U twin squared technology. They actually put a mix of that just to see how those technologies would integrate into that. As I said, this was a proof of concept, it's not a final design.
Sorry, if you can't read it from where you are, basically out of the 2 racks that you're looking at, all of the compute horsepower is on this side, with basic switching to enable its connectivity. So this is all of the blade chassis to do the compute. We've then got Arista network switches that sit at the top, which actually enable all of the connectivity amongst all of the subcomponents that are actually running. And then we've effectively got 2 NetCenter store pods that are sitting in here. Those are actually 2 HA systems. So there are, we talk, or you will see documentation that says that we're running with 4 heads. To be absolutely clear, what that means is that we're running with 2 clustered HA pairs. Okay? So they're actually managed as 2 HA pairs.
And actually, for the hands-on lab, they weren't running active-active clusters, they were running in an active-passive configuration. So effectively, we only had 1 head from each cluster serving data for the hands-on lab portion of this test. They're backed by 3 60-bay Data-on JBods attached to each HA cluster pair, and basically we use our RAID Z2 technology across those with multiple HBAs to create no single point of failure in that storage solution. If anyone's interested, they are running nearline 7200 SAS drives. They are not running 15K high-performance BIOS drives. So, as you probably guessed, cost per terabyte was the primary design configuration.
So, focusing primarily on the NetCenter store box. We've given up on talking to you about the actual the compute side of this. This is purely on the storage side.
So, that's the bill of materials that we have in the pod design from the NetCenter side of the house. And as you can see, it has 362 terabyte nearline SAS drives in it. And as you see when we talk a bit more about the workload that you're actually asked to do at VMware, that's one of the design choices that if you were asked to run the labs that you might have not considered. But it is testimony to the platform, and you can see when you hear us talk about NetCenter Store and we talk about being able to leverage lower spindle speed drives with the aggressive caching technology that we have with SSDs, with the hybrid storage pool, on what level of IOPS performance you actually can deliver on a platform based on those drives.
Actually, I recognise some faces, obviously, but we did some training earlier in the week. How many people did the training earlier in the week? Okay, so we kind of called your bluff during the week and we forced you to actually do some design, and then we threw you some curveballs in the middle of it. It's effectively exactly what we were thrown with this. But hopefully, if it does nothing else, this will prove to you that even if you well-architected a solution in the first place, even though it was a quite different deployment that VMware turned this system to, it managed to survive quite happily. Yeah? It was just a case of rejigging the architecture of the pool and the variety of SSDs that were actually being used that meant the whole solution was more than capable of doing setting up for the next alternative deployment.
The cloud deployment, because it's not quite so aggressive on IOPS, is actually an active-active cluster with 2 pools in each cluster, but as I've alluded to, that is the one change we made from the actual Super Rack design for implementation. It's a fairly easy change for us to make. The per pool design, as I said, was 6 drives in a RAID Z2 layout, which means we picked 2 drives from each of the JBods. We have double failure redundancy at the disk level for each of those VDEV sets, which means if somebody was to actually take a JBod out of the solution, that a solution can continue running in its entirety.
If you're not familiar with RAID Z2, if you're not already running our solution or another ZFS solution, then the closest analogy here would be RAID 6 or RAID DP, as you might see it from some other vendors. So it's dual parity, okay? So we can afford to lose 2 drives, and consequently we can afford to lose 1 JBOD in the solution and still survive quite happily.
Okay, that gives us 30 virtual devices per pool. We, in addition to that, we augmented each of those pools with some S-Tech Zeus RAM as write cache, and we also have some S-Tech read caches assigned to those pools. Okay, that's 360 drives, that's 720 terabytes raw, that's 480 terabytes in a usable format. Also in conjunction running the hands-on labs with us were NetApp and also EMC. Basically it's a joint technology project with VMware. The design of the hands-on labs is to showcase VMware's latest technology and their partners' vendors' latest technology. And the main focus of that event is for those partners to help VMware deliver a fantastic user experience for all those people taking the labs. There's 487 lab seats, 487 people come in and they expect to do 1 hour's worth of training, and it's that user experience that they receive that proves to them that we can deliver that sort of level of virtualization across the cloud to a desktop, okay, in a real world environment, and that is the point of the lab. So we were there alongside those vendors to deliver the best user experience we could. And obviously, when we were invited to run the labs, we had some concerns about that because the platform wasn't designed for that workload. As you can see in the design choices from our co-partners, they designed for IOPS, right, in those solutions.
I think everybody would agree they're pretty up-spec configurations. Okay, if any of you kind of work with other partners.
Okay. What I would like to point out is we didn't need a 362 terabyte drive to deliver this. Okay. I know that some of our the other vendors involved have a lesser number of disks. It was what we delivered in the platform, so that's actually what we delivered the hands-on lab. We actually didn't need that number of spindles in order to deliver what we delivered. But as you can see, NetApp delivered 144 15K hard disks. They had a large amount of read cache in each of their heads, and that's a non-volatile RAM cache in those. EMC chose to deliver 2 VNX clustered platforms. One of which platforms was a complete SSD play for them to showcase their technology of a complete SSD delivery. And one of the other VNXs was based around 15K disk technology with SSD for fast cache and fast BP SSD tiering for some of the particular file types that VMware gave us.
This is a workload that you see nowhere else on Earth. This is a workload that no other vendor can generate. This is frankly a workload that not even VMware understands. And to give you an idea of that, they're using beta and pre-beta software to do the deployments. This year the deployment, or last year the deployment was made with Lab Manager. If you're familiar with the VMware environment, Lab Manager. This year the deployment was made with the brand new vCloud Director software. vCloud Director was not even released to customers until the day of the show. They were running with beta software for 6 months before the actual show to try and get it up and running. So they discovered bugs during the run of it, and they fixed the bugs during the run of the course of the show as well.
And let me be clear, that's why VMware do this, and that's why they choose a number of partners to work with, because this is them field testing their software. Yeah. This is a great way. It's a testimony to the product that VMware deliver is the fact that they test it to this level of the extreme. Okay.
And more importantly, in the open.
Yes.
It's quite astonishing actually that they do that in front of all of their customers. To be perfectly honest.
Yeah. And the IE team were a pleasure to work with because they're used to working in this environment. From our point of view, working in this environment has advanced our product massively in terms of we couldn't put up a test environment like this. The actual end goal is so that if you were in a cloud operations center, is that your operators could look at a plasma screen and get an instantaneous view of what their storage is going on. Bar graphs, line graphs, spark graphs, all of those things are great, but you have to analyse them in detail. And correlating information between those individual graphs is incredibly difficult. So Craig's goal was design something that we could actually look at as a single graph that gives you all of the critical information about how your storage platform is performing.
So, as Andy says, convey as much useful information as we can, as densely as we possibly can. High level, as I said, useful statistics. Let's get away from low level byte counts, etc., because they don't really mean an awful lot to most people. We're interested, therefore, in seeing NFS operations. We're not really interested in raw statistics coming through the box. The other thing we're interested in is we want to move this up a notch. We're not interested in worrying about a client particularly. We're worried about knowing about VMs, and we're worried about knowing about VMDKs. To give you an idea, one of the things that we've subsequently investigated and we delivered for Copenhagen is how many people actually deal with VM alignment issues. Block alignment, yeah, and file system alignment within VMs. Bit of a bitch to work with. We can tell you whether every single I/O that occurs that writes to a VMDK is actually aligned or misaligned, and by how much of a degree is misaligned. We do that for every single I/O that comes in and out of the box. Okay? And it's done with effectively zero overhead as far as we're concerned, as long as we do it correctly. So, the response was, all of this was driven by the NOC. I know Andy says that I was pretty dumb enough to actually go up there and say, hey, what if we could produce this? But the reality was that as soon as we did that, we got lots and lots of feedback. And that feedback was gold to us as well, because it told us what a big management operation like the NOC team actually wanted out of their VM monitoring. Subsequently, we're looking for your feedback as well. So please, if you've got any feedback and you see me wandering around, or you see Andy walking around, or even Richard, he does walk around as well, and he does look normal most of the time. Then please take us to one side, tell us what you think, good or bad. We're interested in your feedback, okay? By no means is this a finished project, by any means. It was just literally something that was written up over a day or two. So, what are we aiming to deliver? The aim was to deliver some visualization of the bandwidth utilization, the flow of traffic, the read and the write percentages, or to give you an idea of the breakdown between the reads and the writes. We responded here to VMware input. They are particularly interested in, sorry, it's a bit low on the screen. They're particularly interested in the top 10 issues, top 10 clients. This is not a view we particularly hold very dear to our hearts. This is just something that was a direct response to VMware. They decided in the NOC, hey, out of all of these 480 seats, and our 28 labs that are actually running, or 26 labs, sorry, there's a few of them that are normally critical to us. That's normally shown up in the top 10. Really what we're looking at here are things that are hogs. If one VM is actually hogging all of the actual operation of a box, then it'll show up in the top 10. Which server, the latency, and subsequently in Copenhagen, the alignment. We did this one in Vegas via a script. We actually provided it within about 10 minutes of being asked for it, but we provided it in a script that was running on the desktop in the NOC. So when we got to Copenhagen, we revamped the design a little bit. I'll show you two different versions of the graph.
This is Craig's entry into the International Arts Awards 2012.
Nobody
Would you like to vote for this?
So this is a damn good reason to never take an iPad with you into any meeting, okay? This was a sketch that was drawn on an iPad, literally sitting in front of the guys in the NOC as we were chatting to them and saying, what if we could do something like this? And what if we kind of... So the idea was, traditional bar charts, pretty passé, but they work. Most people understand them. They give you a nice context, they give you a nice history. Proportions of read and write, you'll see where this one comes in later on if you remember it. To also give you a textual table so that you can get percentages, you can get returns. And then the main thing was to give you a much better visualization. If you're interested after this, we can talk about the inspiration for this one. This is inspired fundamentally by some really fantastic visualization work that's been done in the gene kind of mapping area. And if you look at some of the design work that those guys have done, it's quite awesome. The problem is that it typically takes them hours to generate the actual graphs. Our challenge is that we were aiming to deliver this in typically with a 5-second update interval. We could deliver it with a second update interval, but we were looking to do it in 5 because you need to actually absorb some of the information that's there. So,
what did that turn into? That turns into that.
What you just saw turned into this in approximately a day and a half. So to give you some idea, this is what we subsequently branded because we got fed up with calling it all sorts of different graphical names, aura charts, for no other reason than it looks a bit like a halo and an aura. So subsequently, what does this actually tell us? We delivered on the kind of idea of NFS ops, past 5 minutes worth of NFS ops. We delivered on back-end IOPS, past 5 minutes, and the peak sizing that you see in both of these. What I'm sure none of you can read from where you're sitting, but I'll tell you what's on there anyway, is we then succumbed to the demands of VMworld and said top 20 files being accessed. Notice top 20 files being accessed. We were deploying an NFS solution. The NFS solution, we could monitor individual VMDKs that were being accessed. So this is actually reporting latencies and also throughputs to individual VMDKs. This calls up the name of the VMDK, so you're actually told exactly which VMDK it is. And in this case, the only thing that was requested was NFS ops. So we gave you an individual NFS operations count broken down by all of the traffic that was occurring within the lab environment against a single VMDK. So if you've got a VMDK that's hogging things, it's going to show up very, very quickly here, and that's exactly how they used it.
Subsequently, they asked us to deliver the latency to the VMDK box.
Here are the other bits and pieces. We've got 4 controllers in use. So we basically gave them a button in the top that told them which controller they were looking at and allowed them to change across so that they could look at each of the other controllers as well. Down in the bottom, again, we succumbed to probably, I guess, in some, a bit of vanity in one respect, but also some throughput in the figures that they wanted, which were the total number of gigabytes that were served by this machine, the read and write proportions that were occurring at this point in time, and also a total number of operations that's been accomplished by this machine since the start of the show.
Truth is, Richard got lazy looking at screens and just wanted a big number that he could look at.
The numbers are not particularly easy to read because we're talking about billions here, so we really need to break these down by triplets and actually put commas in there, but we didn't get around to that. We were a bit rushed at the time. So, the rest of the graph, the visualization idea of the graph, is pretty simple, really. We talked about doing the top 10 machines. So fundamentally what we did was we represent NextEnterStore itself as one device. So the orange blob, by the way, before somebody complains about our color blindness, green and orange is obviously the corporate colors, so there was a little bit of a bias here anyway. Thankfully, it's not as shockingly green as these awful bags that they handed you out. Okay. But the orange here represents the server instance. The green, starting from this position and going around in a clockwise fashion, represents the top 10 clients. The top 10 clients are actually represented. Each segment, if you think about each point on the clock face, each segment represents one of the top 10 clients.
Now, actually, the one running in the NOC has some IP addresses, so you can work out who the client is, but unfortunately, we can't expose to you VMware's real client IPs.
Because remember, these are
there is some information in those segments.
Okay, so there would normally be a tag that associates with these in much the same way as you say NextEnterStore, others. Others is a catch-all. Basically, we've got the top 10 here. This is everybody else rolled up. Other than that, some information that's embedded in here. The scale of the segment that you see, so in other words, how large the segment is in terms of expansion, actually gives you an idea of the consumption of bandwidth that that client is doing at this point in time. So the bigger the segment, the greater it is. If you think of it in terms of height, I suppose is the best way to express that. It's actually going to tell you how much bandwidth is being consumed by that client. So at this point in time, looking at that, they're all relatively even. It's a bad snapshot, really. I'll show you an example later on if you want to see it. The 2 bars on the outside, the green and the blue, actually give you an idea of the proportion of read versus writes. So at this point in time, we can see roughly how much bandwidth is doing compared to the rest of its neighbours. We can see the proportion of read versus write. This one's pretty even. This one, on the other hand, is doing pretty much a what? Well, in this case, this one is actually doing a read. So this box is doing pretty much 100% read. There's negligible write. In fact, there's 0 write showing up on this box at all.
And how do we know that's a read? These cords that you see that go out to each segment show you the direction of the flow of the data. So as you can see, this cord is going from the NextCenter appliance to the virtual machine host.
And by the way, if you take a complete segment size, the proportion of the width of this, if you notice there's a much smaller proportion here versus this one, that gives you an idea of the proportion of the overall bandwidth into the device that's being consumed by this read or write. So if you see a reversal of this flow, for instance, this one starts very small and actually ends up going into this as this wide span, that's actually telling you that there's a write occurring. So in this case, what we're seeing is proportion of reads versus write is pretty similar. But the amount of data, remember there's a difference between the number of reads and the number of writes and the amount of data that we flow. So this tells me reads versus writes, what proportions. But each one of the writes could be for very, very large. Imagine a vMotion, for instance, 64K at a time. So it's moving a lot of data. That actually entails quite a lot of bandwidth utilization. And then the kicker, the number one best feature of this as far as I'm concerned. If you're in a VDI environment, what's the most important factor? IOPS. IOPS? Who said IOPS? Who the hell said IOPS?
You weren't on the training, were you?
Yeah, you didn't come on our training class, no?
Because if you did, we failed. Miserably.
Latency is basically delivering the desktop environment, and the desktop environment is all about user interaction. It's user experience. It's latency that kills you every time.
And not just in a VDI environment.
Yeah.
Remember we told you they were nested VMs.
Yeah.
Latency in the primary VM is going to propagate itself down and increase exponentially the more VMs we deploy into that.
So, what we need is a way to actually convey to you which one of these is healthy, which one's unhealthy. Effectively, the color scheme that you see being used for these cords, the color scheme intimates to you the latency. The lighter the color, the lower the latency. Okay? Ultimately, these span from a very, very light green range through to a shockingly bright crimson red. Believe me, by the time they reach a shockingly bright crimson red, you'll have enough people coming off the show floor that are screaming at you that their desktop environments are completely frozen up. Yeah? Because you'll be looking at shockingly bad, over 10 to 12 millisecond latencies. And that means impossible. You know, I move the cursor, nothing happens. I get no response at all from a Windows environment. Yeah? So this actually gives us an idea of what's happening live as far as the latency is concerned. How good is the overall latency view of the system? Yeah? So in terms of packing information into one diagram, we've effectively put 6 to 7 different aspects of the operation of the system into one coherent diagram. If you sit and you watch this running, I think it gives a pretty good idea of what the hell's going on within your environment. We subsequently took this ran in the show, it ran in the NOC, it was used by VMware. We've got some lovely videos, which I'll share with people individually, but I can't do otherwise, of people in the NOC going, holy, some bleep, look at that graph. And it's like they're literally sitting there going, oh, look at that, it's all gone red. I wonder why that might be, okay? But the other one that we've actually got is that subsequent to the show, we took this away and we refined it a little bit. We didn't, frankly, spend an awful lot of time on it. We consider this to be a prototype, a disposable prototype. So we will be doing this sort of work for future versions, but we don't know exactly how they will look. I'll show you the 2 old versions. You see the old versus the new. So what I'll do is, whilst Andy's maybe, well, we're trying to field some questions, I'll try and fire you up a running version of this, and we'll be able to run on this. So, any questions? There you go.
Does that mean no more speedometer dashboards on login?
Yes!
Yes! I personally absolutely detest the speedometer. I have made it my mission since I've joined this company, to see the end of the speedometer display, and I'm quite happy to say that to anybody who listens.
So
the other thing is it will also mean that it sees the end of Flash as a unified front end for our product. No Flash in our product. Yeah, all of this will be delivered by HTML5 and CSS and standard technology.
So removing the speedometers and being able to boot from video and keyboard and mouse rather than from a serial terminal have been our mission for the last year in TechOps.
So, any other questions while we're doing this, and I'll try and find you...
I'll take some of the utilities we just have asked because this is an email, I know. How did your competitors fare?
That's a very loaded
If
question.
you'd like to Google on the internet, I believe EMC have posted some of the statistics from their appliance. As we said, this isn't about how everybody did against everybody. It's about delivery of service to those 487 people on their desktop and making sure they have a good user experience and that they come back year after year. There are some statistics out there from one vendor. The other vendor, I don't believe, has published any numbers. We have our numbers that are publicly available on what we delivered. Like I said, it's not a competition. I think they delivered a similar workload to what we did.
You said you had some things you do differently than you learned.
So if,
configuration?
Well, actually, we coped, as you saw, we actually coped really quite well. The platform could deliver that. But if someone came to you and said, you're going to have a high IOPS workload where you destroy and create a whole pile of VMs, and you had a blank canvas of a piece of paper, you might not have chose 72, and latency is incredibly important, you might not have chosen all 7,200 RPM hard disks, right, of honking 2 terabyte capacity. But as I said, we coped quite well. Any other questions in the room? Look. Did you come on the train? No. Okay. We have something called the hybrid storage pool. So basically, the caching technology and our use of SSD and the use of RAM within the Nexent Store appliance is incredibly aggressive. We typically see cache hit ratios in excess of 90% ratio. And it's that caching technology that enables us to deal with this. Our caching technology has a couple of features. One is a lot of people have first in, first out caches that invalidate themselves quite quickly, especially with this type of workload. We have something called the ARC, the Adaptive Replacement Cache, which is an adaptive learning cache. And it's that caching technology that allows us to cache a chunk of this in the SSDs and the RAM that you saw to be able to deliver such low latency.
But sorry, by the way, one thing to follow that, and I'll show you the figures later if you want to, from Copenhagen. At Copenhagen, we ran with 0.02 millisecond on for a considerable amount of time on most of one of the appliances. We were delivering, sub 100 of a millisecond.
So we actually managed to squeeze their workload into RAM.
The working set size actually ended up in the RAM and the SSDs of our appliance, and as a consequence, we didn't touch disk for a considerable period of time. What is normally termed for trading floor standard, so it's extremely low latency, guaranteed latency. But not to take it away from Arista, but that's not a fundamental time delay that was introduced here. It would still have been the storage. The networking time is not insignificant, but they're very, very good switches.
Question before that networking or switching, was it the NFS requirement posed by VMware?
Yes. So VMware requested file. The reason they requested file was they believe that file is more scalable for cloud-type architectures. You try managing hundreds upon hundreds of high-SCSI loads in that type of environment. File makes it much easier to deploy that, and we're actually seeing that for more and more of the virtualization vendors where they switch back to NFS. There is a big focus on those vendors going back to NFS. Also, NFS is a little bit more resilient to network issues compared to iSCSI.
So, you really put limits on the latency mass house caching performance, because that particular situation I was expecting as caches is that hundreds of flows very similar with the OSs are then work, so push out very high.
Not all the workloads were linked to clones or clones. So there is actually a fair amount.
Isn't every guest was a unique OS?
Not every guest was unique. Yeah.
Still myself. How do you go about taking the latency is by masking up some caching?
So we can look at the latency at the disk level with dtrace.
Okay. And I can look at that as well?
With the current, as a visualization, no. With a dtrace script, yes.
Turning it into a visualization would be a matter of minutes. By the way, this is the second generation graph, just to kind of interrupt Blue. We tried something different with the second generation graph. We went back and we re-implemented some things. We responded. The colors haven't come out very well on here, so it's washed out of the projector. But we tried some different things. One of the things that one group of people didn't like was the actual rings around the outside. So consequently, they got changed to these two in the center. And the color scheme is different. Before somebody says, but it's all red. No, the color scheme was actually deemed to be different for this at VMware's behest. Frankly, personally, I think this one is less successful than the original. The original had a very interesting side effect. If you see an all-read workload or an all-write workload, those little rings on the outside actually go to a solid blue circle or a solid green circle. Completely unintended side effect of the way that we implemented it. We were all shocked when we saw it for the first time, but it actually ended up being one of the better features they actually implemented.
What I do like in the new version is the new graph.
Yes, to give you some idea, somebody mentioned earlier on about latencies. We've changed this slightly because we've added more information. We had the information to hand, but we never put it up there previously. We now have NFS operations on a VMDK basis, bandwidth, latency in microseconds, and the bandwidth delay product to give us a ranking or algorithm. The latency here that's measured in microseconds, just to give you some idea of the numbers that are going past, these are 2-digit references that are going up the screen. Okay? They're low 3 digits and predominantly 2-digit numbers that are actually going up the screen in terms of microseconds.
We have another question.
Response time.
So tuning, well, how much out of, so you know, you're out of the box, you know, the parameters.
We just rocked up the day before the show, deployed it out of the box, and then went down the bar. So we did do, I wouldn't say we did an excessive amount of tuning on the
Actually,
platform.
can I be clear here? If I had to classify what we did, I would not say we did a significant amount of tuning. I would say we did a significant amount of analysis. We actually analysed what we believed to be the workloads significantly and ended up telling VMworld quite a lot, surprisingly to them in some cases, as to exactly what their workloads were. In other words, we analysed workloads flowing between vCloud Director, which was doing the automated provisioning, no human intervention in this provisioning, by the way, and the way that it was deployed to their back-end ESX instances. And we were telling them things that they were surprised by, such as the average block sizes that are being moved back and forth here are 64K. No, they're not. We thought they were 32K. Well, we can tell you categorically, here's the proof that these are 64K block moves. Oh, we'll have to go and investigate that with the vCloud team. And they did, and they scurry off, and they come back a couple of days later and say, actually, yeah, we can see why it was 64K. So it was a case of best understanding the workload, more really than tuning our solution. Our solution really, it was a product of the pool design, and the layout of the architecture of the pool, and also making sure that we were doing active monitoring. So we were monitoring, for instance, ARC utilization, ARC statistics extremely heavily. We actually sat there and watched the ARC and looked at how the ARC was actually doing. But frankly, an awful lot of this we didn't have much control over because we were just subjected to the workload.
We made some changes. We changed some ARC fill rates, and we made some changes to some of the performance tunables based on the analysis. What the key thing in here is the dtrace that we have within the product enabled us to analyse that workload and optimise the platform for delivery of that particular workload.
Dtrace allows us to complete the loop, find out exactly what your workload is, and consequent to knowing what your workload is, tune appropriately and actually come back around the loop. So frankly, one of the goals as well, we haven't, this is a very, very small part of a very large project. One of the goals of the project overall, which this is just an example of one tiny aspect of, is to provide you directly with dtrace access in a graphical format, so that you don't have to do the hacking on scripts that we frankly did on your behalf. Having said which, most of the scripts that we utilize, we're quite happy to give away to all customers and run on their systems. They're scripts that we have written and we hand out on a regular basis, certainly within my team and the kind of engagements that Andy does as far as kind of PS gigs and also the solutions team. So for instance, monitoring at an NFS level, monitoring at a SIFS level, those scripts, those fundamental scripts. How many people are familiar with TOP? Okay, right. Imagine a NFS TOP. Imagine a SIFS TOP. Okay, and that's exactly what thankfully Richard has spent considerable amount of his time writing. Imagine how useful it would be to see those sorts of statistics, from which this is derived. In a simple
I like that. I think that's a great angle.
Sorry, negligible, less than 0.01 or 2% overhead on the system. Yeah, that's not to say you can't. You can make a mistake, but couldn't be correct. No, coded from scratch. In C. OpenGL. That's not to say it will be in the future. Believe me, it won't. But this one for the show was an OpenGL delivery.